Graphing exponential functions number 82. Start off with f of x equals 1/3 to the x power. Basically what we're looking to do is this. Whenever you want to graph an exponential function, which by the way is a function that has the variable as the exponent, you want the exponent as a -1, a -2, a 0, a 1, and a 2. That's what we want to do. We want the exponent to be -2, -1, 0, 1, and 2. These are the easiest function values to find. You see, if x is -2, we're going to get 1/3 to the -2 power, which 1/3 to the -2 is just simply 3 squared, which is 9. Alright? So we're going to graph the point -2, 9. That's going to be right about here. We're going to do -2, 3. I'm sorry, -1, 3, 0, 1, 1, 1/3, and 2, 1/9. So what happens is our graph is just going to come down, grab those points, and get closer to 0 as we go to the right. Okay, so this would be the function f of x equals 1/3 to the x power. Alright, next one, g of x equals 4 to the x. Same way, we want the exponent to be -2, -1, 0, 1, and 2. Okay, so we got -2, 1/16, so that's going to be just barely above the x-axis. -1, 1/4, 0, 1, 1, 4, and 2, 16, which is going to be way up here. Okay, so then our graph would come down like this, and we would have a horizontal asymptote at the x-axis. Okay, notice how this would be exponential growth, as we have 4 is greater than 1. This would be exponential decay because 1/3 is less than 1. Okay, that's how that would work out. Okay, now here is where what we were talking about earlier comes into play. You see, now you have k of x equals 4 to the x plus 2. Well, what's going to make the exponent -2? Well, x is -4. Okay? What's going to make the exponent -1? -3. What's going to make the exponent 0? -2. So we still plug in, we're still trying to get the same output with a different input. Now, if we know anything about translations, we will know that this graph, the only difference between these two is you're adding 2 to the x values, which means this graph over here, k of x, is going to shift this graph to the left 2 units. Notice the x values. See that? To the left 2 for those. So it's going to look identical to this, except it's going to be moved over to the left. So -4, 1/16, -3, 1/4, -2, 1, -1, 4, and 0, 16. So there's our graph. It shifted. Actually, it's going to be like this. Okay. So it shifted to the left 2 units. Alright. Now the last one. H of x equals 4x minus 3. We subtract 3 after we've performed the exponential operation. So what's the difference between these two graphs? Well, we're subtracting 3 on the outputs. See that? We're going to subtract 3 on the outputs. That's going to move this graph here down 3 units. So instead of -2, 1/16, we're going to have -2, 1/16 minus the 3. So let's graph these two here. Let's start over here. So 2, 13. All right. 1, let's see here. This is going to be 1, 1. Okay. 0, -2. Okay. -1, well, this is about negative, well, it's actually exactly -2 3/4. So we're not going to quite make it down to, looks like we're not going to quite make it down to -3, are we? So we're going to have a horizontal asymptote at y equals -3. So we're going to get closer and closer to -3, because this could potentially get closer and closer to 0 as x gets smaller and smaller as we approach negative infinity. Alright, so this would be how to graph exponential functions. Good times.